Hey everybody, welcome to the OpenUSD Insiders live stream. Our topic today is a fascinating one, how urban simulation is building better autonomous delivery. We have a very special guest, or two special guests from Coco. We're going to be introducing them in a minute. But my name is Edmar. I'm the community manager here at NVIDIA Omniverse team. As I mentioned, we're going to talk about something super fascinating, not just in the controlled lab environments, but actually on city sidewalks, pedestrian construction, delivery zones, all the chaos of urban life. How does that all work, and how do you leverage simulation to effectively have these autonomous delivery vehicles walking around the streets, as you might see if you're in a city like Los Angeles, where our guests have some stuff running today. We're going to get into that in just a few minutes, but first, we wanted to start with a very special segment, a new segment called Build of the Week, where we're going to show off something very special. And that's why I brought my colleague Max here. And Katie's also here to talk about a very special announcement before we bring in the Coco team. So we'll start with Max, because Max, you have something very interesting to show off. There's been a lot of talk lately from the NVIDIA team and from the developer community about skills and how to use skills, but let's set the stage and tell people about what skills are. And then I think you're going to actually talk to show us how to use a very specific skill, correct?
Yeah, that's right. So we, over the past few months, we've been taking some of the really interesting core components of Omniverse Kit and releasing those as libraries. And to go along with those libraries, we've been creating skills for coding agents to sort of learn out of the box what to do with those libraries. And as more libraries have come online, we're now releasing skills to help your agent sort of stitch these libraries together into interesting workflows. And so at Computex, we released two new libraries. We released OV Stream, which is our streaming library, and then we also released OV UI, which is taking some of the core UI framework systems out of Omniverse Kit and making that its own Python library. So to go along with those releases, we released a whole bunch of skills that we've wrapped up. We call them the Omniverse real-time viewer skills. And really, they're there for your agent to just point your agent at these skills, and you can start to build a real-time interactive application on top of these new libraries.
Amazing. I see you have some slides here. Do you want me to show those up?
Yeah.
Okay, here we go. Okay, we see them.
So we kind of started with like a really simple hypothesis. Anyone who's worked with Omniverse Kit and built a streaming kit application, they're probably familiar with the web viewer sample. This takes an Omniverse Kit viewport with RTX, a USD stage, and then streams it to a web front end over WebRTC. And then we wrap a really simple React UI around that. And then that front end can communicate with the back end. And so at Computex, we realized, okay, I think we're going to have enough libraries to now actually recreate this sample just with libraries and agent skills. And that's exactly what we did. So like feature for feature now, we have this entire sample able to be created just with those libraries and just with skills. With your skills and a pretty simple prompt, your agent could get this entire workflow up and running in around 15-20 minutes. It depends on what harness you're using. But it's super exciting when we find that we distill down core components of Omniverse into libraries, really describe the API surface area of those libraries in our skills. Agents can put these things together super quickly.
That is super exciting, and I'm sure developers will love leveraging this. Oh, cool.
So just to kind of give you a view of like what are these skills, they're kind of broken out into categories. So sort of these purple areas are sort of the buckets of skills that we've made. So we made skills for web-based clients, for local clients. We have skills for the UX and the UI of building applications like this. And you can see we're going to route your agent into these buckets, and those agents are then going to go see what libraries to go pick up and bring into that. So they'll go know to grab OV Stream and OV UI and OV RTX. And when we kind of put these things side by side, that old kit Omniverse web viewer sample, that's sort of there on the left, and on the right is kind of how we recreate that with libraries. So it's a much more streamlined architecture. Much more of the application is sort of owned by the developer in that custom Python that they build for the server, and also the custom web front end that they build. And so I kind of like to think of these skills, and how I tell people to sort of think about their prompts is kind of take a layered approach, right? Like, grab these skills, ask your agent to just build me really simple USD viewer that's going to give me an interactive viewport and stream it into a web page. We have skills that, if you don't have any USD sample data, we have skills that can go grab a couple sample stages for you and pull them in. And then think about how to like grow that complexity with additional prompts once you sort of get your base application working. So, add things in like the ability to pick prims, manipulate prims, show properties about things that are in the stage. We have skills that pull in other libraries like OV storage. So if you wanted to start to pull that USD data from an S3 bucket or something like that. And then finally, there's skills to containerize this application and then deploy it from the cloud. And so one that I love is we have skills in here that leverage Brev. And so, Edmar, let me switch over to my Brev instance real quick.
Yeah, and for people who aren't familiar with Brev, that's NVIDIA's GPU access in the cloud. Super impactful, making things very accessible. Let me add this to the screen. There you go.
So we have a Brev launchable that your agent can stand up really quickly, and here it is running live just on a simple AWS instance on Brev, and I can pick these things. And what's really fun is inside OV Streamer is not just WebRTC, but also RTSP. So I think I sent Amelia a link. We actually have an RTSP server running next to this. So let's say you're doing a really cool demo like this, and you want to make sure all your users are seeing a full 1080p, 30 FPS stream of it. We actually, on Brev, we have a public URL that people can hit, and you can see me interacting with this stage in real time. And so, that can scale up to quite a few users, which is a lot of fun.
That's great. Very cool. That's awesome. I think Amelia's posted those links in the chat. We'll also update the video description. Max, this is so awesome to show off on the live stream. Thank you.
Yeah, it's been a lot of fun. I tell people, like, with these libraries and these skills, I'm really excited to sort of see what kind of new interesting places people take Omniverse RTX and USD. With OV Stream, you can put it into some pretty cool workflows that we couldn't do before with Kit.
Amazing. And where do you recommend people go if they want to chat or more about it or get support?
Yeah, so of course, hit us up on Discord or our forums. And then we actually do have a skills repo on GitHub where all of our physical AI skills are posted.
So the maybe the issues area there on the GitHub page?
Mm-hmm.
Okay, perfect. All right, Max, thank you so much. I really appreciate you coming on and sharing this today.
Yeah, thanks for having me.
Okay, great job by Max. Now, Katie, we have more great things coming up today. I'm so glad you joined us. We have a couple great developers waiting in the wings from Coco. But you also have a very exciting announcement, which is pretty hot off the presses. I know some of the developers that we've been sharing with over the past couple of days on our Omniverse Discord server have just been going crazy over it. So tell me what's new in the world of Isaac Sim, and then you can help introduce our developer partners here today.
For sure. All right, let me share my screen.
And while Katie's bringing that up, for anyone who's not a member of our Discord server, I highly encourage it as a place to go if you want to engage with other developers in the community. It's just a fantastic place to share your project or ask questions or to learn from other developers. And I think I see your screen now. Here you go.
Okay. All right. As I think I saw some of you point out in the comments, Isaac Sim 6.0 is officially in GA. We are very excited to announce. And as Max was saying, we are incredibly invested in making our technology agent friendly. So with this release, we have a new MCP server, so you can connect your Claude or your cursor agents to let you control running instances of Isaac Sim. We also have Newton support expanded across robot import, authoring, and software in the loop testing. So now policies trained in Isaac Lab can be tested against Newton in Isaac Sim, making that sim to sim transfer much easier. We also have a browser-based GUI, so you can stream the full Isaac Sim interface from any Chromium browser without needing any local install. Also very exciting, instead of having to render every single sensor when you're just looking to capture data from one, you can now render sensor data independently with multi-tick rate integration, making that much more straightforward. And we also have support for Isaac Teleop, so you can collect data seamlessly in simulation. So with that, so we're really excited for Isaac Sim 6.0 to be available. We also kind of, I think it was last year officially open sourced Isaac Sim, and really see it as an open framework for developers to take it and use it for their specific needs. We've had people build ocean simulators or take it to the airspace. And now our partners at Coco Robotics have built an entire urban simulator on Isaac Sim to test their delivery robots. So we're really excited to have them show off what they're doing, and really encourage everyone listening to try out your own solutions. Let us know, share it with us, and maybe we will see you on the live stream.
Awesome. Thank you so much, Katie. I really appreciate it. I have to tell you just right off the bat that I haven't seen the developers get so excited about a release as they are about Isaac 6.0. There was a lot of emojis when we posted it on the Discord server. So a lot of yeah. So thank you for going that with everybody. And again, for people who want some official support, the GitHub page for Isaac Sim, the issues area, or you can leverage the Omniverse forums for Isaac Sim, and of course our Discord server, like I said, for user-to-user support. All right, Katie, thank you. I'm going to bring in our special guest, but thank you for teeing things up.
All right, thanks, Edmar. I will see you all later.
That's great. Okay, so now I'm very happy to bring on Brad and also Bolay from Coco Robotics. Thank you so much for waiting in the wings. We are very excited about today's live stream. And for people watching, if you have not heard of them, you may have seen some of their work if you've been walking around some cities and seen some autonomous delivery of robots walking around. Coco operates one of the largest autonomous sidewalk delivery fleets in the world. And what's cool is how central simulation is to your whole development process at Coco. And that's what we kind of wanted to dive in today. How you're using Isaac Sim to build, test, and validate your autonomy stack before deploying to the real world. Brad and Bolay, do you want to give a quick overview of things? And then I think we have a great video we can play that gives people more context, and then we'll dive into things.
Yeah, I can start. So I'm Brad. I'm one of the co-founders and CTO here at Coco. Kind of today, I'll go through a few slides kind of introing the company. Bolay is going to dive into some of the great work he's done with Urbanverse and kind of help getting all those assets stood up in Isaac Sim. And then I've got like a kind of quick demo showing how one might train an RL agent inside Isaac Sim using Isaac Lab.
Super exciting. Okay, so Bolay, we're going to come back to both of you in 1 second. I think we have a great video that Brad just mentioned. We're going to play that. And for everyone watching, get your questions in the live chat. The more on topic your question is, the more likely Brad and Bolay or myself will be able to answer it live. We're going to be back in 1 minute, but let's watch this video to set things for us up. Wow, what a fun video. That's a pretty quick robot you got there too, navigating some pretty challenging terrain in the urban environment. If you're just joining us, we're live with Coco Robotics. We're going to cover and deep dive into how urban simulation is building better autonomous delivery robots. So Brad and Belay, how would you like to start off?
I've got some slides. It'd be great to go through those, give everyone kind of an overview, a little bit more detail on the company if they're not already familiar.
Okay, perfect. And yeah. I see two sets of slides here. Did you want me to show the one that had the video in it or the other one?
The one that had the video in it. Yeah.
Okay, so let me add this to stage and let me just backtrack a little bit here. There you go. It starts here, right?
Perfect. Thank you. Yeah. So we're Coco Robotics. So we are a robotics company with a focus on urban delivery, and kind of a natural first question is kind of why robotic delivery, like why now? So delivery is massive market, and it's only growing. And at the same time, the industry is experiencing labor shortages as well as rising costs. So it's a great time, given there's a real need for kind of meeting that demand. So at the same time as this kind of growing demand for delivery, we've seen like this crazy acceleration of robotics and AI that I'm sure everyone's very familiar with, and it's very much been fundamentally changing how work gets done. So that's why our mission is to leverage AI and robotics to help drive these costs down and make living in urban areas and cities more enjoyable and more affordable. So I wanted to kind of go through our journey and kind of show in the video we played earlier, you might have seen a few different robots. So I thought it'd be cool to kind of go through our iteration cycle, and I think it'll help kind of frame how we got here today. So when Zach and I started this, kind of our whole angle and why we wanted to build this is we felt that the best way to really build a robotic business and to scale that was to first build a sustainable business that got hardware out in the wild before really going heavy on AI, on the AI side. We felt like there was a lot of operational challenges that we needed to overcome. And then once that sustainable business was running, we'd be able to use that fleet and that data advantage to fund all of the AI research and development that we're going to need to do. And it creates this really beautiful flywheel of you have the largest fleet, so you have the most data, so you can train the best models. So that being said, we had to start somewhere, and this is where we started. So Coco Zero. So this was largely handmade. We love this photo because there's there was bad bots and there was good bots, and on this section we have this spray painted sign that says good bots.
Whose garage is this?
This was like our office.
Oh,
basically. Awesome. Yeah. So this is in LA. Yeah, so handmade, super low volume. I think we made like 50 of these. And the main goal here was to kind of prove out our thesis that we could, that like there was product market fit for robotic delivery. So we took the learnings from Coco Zero. Skip that one. And then we built Coco One. So, demand was outpacing supply. So we wanted to build something that we could build a lot of, and we did build a lot of these. So we manufactured over like 1,000 Coco Ones. Wow. So there was still some off-the-shelf components on this, and some custom, but overall it was just larger, more stable, and just a better vehicle for our operations. So after operating these for a while, we saw a lot of things. So we got the Coco submarine right here, actually in LA, when it rains once, everything floods. And then, across some of our other markets like Miami, always raining, like hurricanes, all that good stuff. Chicago, super cold, lots of snow. And same thing with Helsinki, Finland, over in Europe. So the Coco One has seen a lot, and we kind of use those learnings to iterate on Coco 1.5. So it's 0.5 because it's largely the same structure, just we've swapped a lot of the internals and had a main focus on really improving like the weatherproofing of the vehicle. So two big like kind of cold weather items was battery heating and snow tires. So operating lithium-ion batteries in the cold has some challenges. So that's helped us kind of stay operating in areas like Chicago and Finland. Ironically, Chicago gets way colder than Finland, which I didn't think.
I did not know that. Wow.
Yeah. And also better waterproofing and upgrading the cameras.
So it can handle that picture you just showed a minute ago of the kind of flooded streets?
Up to some water height.
Mm-hmm.
And we're always improving it. Waterproofing is like a spectrum.
Yeah.
Which is funny.
Pretty impressive.
Yeah. So here's some numbers. So we've got over 1,000 robots out in the world, thousands of merchants, and we've driven over 1 million miles
Wow.
in the life of the company. This got messed up. That's funny. So you can picture some slide here that showed very diverse, videos from robots operating all across the world. But the main thing here, and as you can kind of see from the like timeline of the vehicle, is we operate, we take those learnings and use that to build better vehicle. So here we can see that timeline. So Dexter was like, didn't even get a number, but Dexter and Coco 0 were basically our first robot. Coco 1 and Coco 1.5 was like the first one we really scaled. And then a robot that we'll be releasing later this year is Coco 2. So really, like, we are a robotics company, but at the same time we provide a service. So our goal is to provide the best delivery service. Coco 2 is 10 times cheaper than a car. Super compact. You might have seen it in the earlier video, but we can fit about like 14 of these in like a single parking space.
Wow.
To give you an idea of kind of how many Cocos it would take versus how many cars and kind of the space implications of that. And even comparing to like modern EVs, we're about 10 times more energy efficient than an EV, which can just be attributed right to a smaller, lighter vehicle. So Coco 2 has 3 main goals. So hardcore reliability. So we've like kind of overhauled the entire robot, automotive grade, kind of everything. We want to eventually move beyond the sidewalks. So we do operate kind of in some non-sidewalk environments right now, like bike lanes and shoulders of streets in some areas. But Coco 2 is really the first one that's been designed for this. And I guess my GIFs don't work, but
Picture it all moving. Picture it all moving.
Yeah, picture it all moving. And then the third goal with Coco 2 is really leveling up kind of our autonomy stack. So if you pictured all these beautiful moving robots, this actually all is running on Coco 1.5. But Coco 2, we're upgrading our compute, upgrading our sensors. So we're super excited to run just bigger models, better models, and just overall like improve the capability of the system. So when you're building AVs, simulation is very important. So, why would you use simulation for testing? And I think it really boils down to 3 important things. So first is a faster development cycle. So any like robotics developers watching this now, right? You want to like make changes and iterate quickly. So there's nothing beats simulation. So you want some sort of interactive environment where you can kind of test this in closed loop. And next, this kind of goes without saying, but like safety, top priority. So testing and simulation lets you let the system fail many times in simulation without causing any real world harm. And lastly, repeatable. So this becomes very important as you're trying to scale the system. So you want something that's deterministic so that, same inputs gives you the same outputs so that when you do have problems, you can reproduce them and keep testing them. So here is a photo of us running Coco in one of our tests using some of the Urbanverse assets that Bole is going to talk about. And lastly, this is like an active area of research, but going beyond testing is also really interesting. So you can use simulation for synthetic data, for improving any sort of perception models, but you can also use it for training AI models. So the real goal here is, how do you create an interactive environment that your agents can interact and learn? So kind of after Bole's talk, I'll go through like a kind of quick high-level overview of how you might use Isaac Lab to train one of these. But yeah, so that's overview of the company. Hopefully that was helpful and gives you an idea of what we're doing and where we're going. But with that, we can hand it over to Bole, and he can really dive into show a little bit more focus on simulation, the assets, and some other cool things.
Amazing. I'm sure we got lots of developers now that are kind of like, can't wait to see the next thing, because that you just made a very impressive case for what you guys are doing. Bole, tell me about your background and what your role is specifically at Coco and UCLA.
Hi everyone, I'm Bole Joe. So I'm a chief AI scientist at the Coco Robotics. I'm also a professor at the UCLA Computer Science Department. So more like I wear two hats. So, but I think the unified thing is I'm a researcher. So there are a lot of interesting research problems in the sidewalk autonomies. So I would like to explore.
Amazing. Well, very cool. I already see people in the chat wasted no time. You already had somebody who wants to come to UCLA. So I guess be on the lookout for their application. Okay, great. So I see you're sharing a slide. You want me to share that on the screen?
Yes, please.
Okay. Here we go.
Yeah, great. So as I said before, so I'm a researcher. So sidewalk autonomy is a very new problem. So there are a lot of interesting research problems underlying of this sidewalk autonomy. So since I joined Coco last year to work with Brad and Zark to design and implement the autonomy research and the development. At the UCLA, I also work with my PhD students and postdocs to tackle the fundamental research and also develop tools and collecting data sets and give back to the community. So today, I would like to give you a brief introduction about our research on urban simulation for sidewalk autonomy. So right now, you can see we have many robots running on the sidewalk, like a lot of delivery bots from different companies. And also we have many other robots, such as electric wheelchairs, right? So elderly and disabled people use wheelchairs to move on the sidewalk to reach some destinations. And also in the future, you can imagine if the humanoids or the robot dogs can happen, those robots will also walk on the sidewalk, right? So they face a similar challenge to what Coco Robots try to tackle, right? To have a safe and reliable sidewalk navigation. So here are some of the eagle view of the Coco Robots videos I would like to show you. So this is from the first person view of the Coco Robot. Then you can see the sidewalk navigation is actually very challenging for physical AI, right? So a lot of obstacles to tackle. And also we have a wide range of weather conditions, right? From raining to slowing to all the like flash flood situations. Also on the sidewalk, we have many like peoples walking around. We also have animals like a dog. People walk their dog and try to interact with the Coco Robots. Also here another one, you can see here there is a dog just lying calmly in the middle of the sidewalk. Then the robot have to really do the delicate maneuvering to avoid stabbing on the tails and avoid collision with other like coffee, the people waiting for the coffees, right? So it's quite challenging for the robots, right? So you can see on the one side, we have the lot of sidewalk robots moving around, but on the other side, we have this unpredictable sidewalk conditions, right? People walking on the sidewalk. We also have people sleeping on the sidewalk, right? Also compared to autonomous drivings, you know, this Coco robot is very small sized, which means we have much less compute, much less batteries. So it's a really constrained compute and the perceptions. It's also a long horizon task, right? Usually, Coco robots have to run several street blocks to achieve the delivery task. So it's quite challenging problem there. So people try to tackle the sidewalk autonomy. So my research focused on this like learning, like robot learning, right? So people tackle the problems from the perspective imitation learning, because Coco have the robotic fleet running around with human teleoperations. Then we accumulate a huge amount of data. Then we can train some models through imitation learnings to imitate human driving behaviors. So over the years, people come up with many like imitation learning and also the visual navigation foundation models from the research literature. So here I list some of the representative works, like from the winds, nomads, city walkers. Also in recent 2 years, my lab also developed many models. 1 week ago, I just presented a paper called Mimic, the ICRA in Vienna. So people develop many this kind of sidewalk navigation foundation models and train on massive amount of data, right? Then people want to deploy on the real world sidewalk. So we have this fundamental problems. How can we evaluate different autopilot models before the real world deployment, right? This is where the simulations and the NVIDIA Isaac Sim can play a very important role. Since 2 years ago, so my lab have been working on the urban simulation platform built on top of NVIDIA Isaac Sim. So this demo video showing you urban simulator we built called Urban Sim. We can place a wide range of urban objects and assets in the environment, and we also can run different sidewalk robots in the environment. You can see we have wheelchairs, then we have a Coco robot or some other robot. You can see here the white sidewalk robot running into the trash bins, the humanoid robot also running into trash, right? It's quite a cluttered environment such that we can really train our bots to have a safe navigation, sidewalk navigation. So based on this urban thing, so we built the evaluation benchmark to evaluate different sidewalk navigation foundation models. So here is a video that we evaluate 9 different models on CocoBot to navigate inside the urban scene scenarios. So we try to test the model, how the model can handle the pedestrians, try to avoid the collisions with pedestrians. And you can see some of the models succeed, some collide with people. We also can do more tests like the crosswalk, evaluate those models to handle the sidewalk crossing, the crosswalk crossings, right? Some robot just get stuck on the cutting. So we have this urban scene that we can fairly compare different models that can indicate which model we should use, and we also can develop many better training recipes to have a more reliable models. But from the previous work, you can see the urban scene is still built on top of Isaac Sim. So the scenarios are manually crafted. But ideally, we want to create the urban simulation directly from the real world videos, right? So then we have this very recent work called the Omniverse that try to create the urban simulations from the real world videos. So between the real world videos and the graphic simulations, so we want to use some intermediate representations to bridge the two. So here we use 3D scene graph to bridge the two. So basically 3D scene graph is a intermediate representation to indicate the object relations and their spatial layout from the videos. So after we extract the 3D scene graph from the videos, then we can place different 3D assets in the environment and create a diverse range of simulation environment. So this video is showing you that giving the same like 3D scene graph extracted from the real world videos, then we can replace a different object instance, then create this kind of a digital cadence. So we have a scene variations that we can use them to evaluate and train our bots. So this Omniverse follows these 2 steps. So first step, we will apply some computer vision reconstruction techniques to extract the scene layout and the semantics from the videos. So that can help us indicate how we place different 3D assets into the simulated environment. So we have a second step, then we annotate very large scale 3D assets with a wide range of physical attributes from the size of the object and their scales and many other physical attributes such as mass and the affordance. A lot of attributes we annotated. So this demo video showing you that after we finish annotating, then we can put all those different 3D assets in the Isaac Sim environment that people can use to create a diverse environment, right? So you can see those objects are in their right relative scales, right? Then can directly use the asset to create the environment. So we already open source this Omniverse dataset to the public. So you can just go to our link and use the assets we annotated. So totally we have 100,000 assets. So you can use them to create on your own simulation environment.
That's awesome. Very cool.
Then you can see here this demo video showing you that we have Coco robots running in the Omniverse simulation environment. So it's much more realistic, and there are also many different objects inside. But from the Isaac Sim simulation, we still notice that the visual appearance is not so realistic compared to the real-world deployment, right? So then we want to better bridge the visual gap, right? So how we can tackle this? So we follow some solutions that we want to create this data-driven simulation like directly from the real-world videos through the neural reconstructions. So in recent years, there is a huge progress on neural reconstruction. So we have a paper published at the published CVPR last year, so called the V2Sim. So basically, this method is a neural reconstruction method that can reconstruct interactive simulation environments directly from videos. So from videos we capture on sidewalk, then we leverage the neural reconstruction like Gaussian splitting to reconstruct the environment. Then we can place different 3D assets, including the Cocos inside the environment. Then it can interact with a simulated environment, and then we can train the robot with reinforcement learning in the reconstructing environment. So this video is showing you this reinforcement learning process. So because the simulation environment is very realistic, then the models we have can have the zero-shot scene to real transfer to the real world. So for the V2Sim work, we also released a paper and also the code, so you are welcome to use. So based on this V2Sim, we at Coco Robotics, we further scale this kind of a data-driven simulation up. So here is a recent demo we have. So we can directly evaluate different models in the data-driven simulation. Now you can see compared to the previous Isaac Sim, so we have a much more realistic visual appearance. So that is benefit from the neural reconstruction. Also, we use NVIDIA NeuRack toolkits to bridge the neural reconstruction and the Isaac Sim simulations. So here are more. We can then evaluate the model for the crosswalk crossings. You can see some models succeed, some model have some failures. Then we can use this feedback to further improve our models. So here I just show you some demo videos. So here is a model that we trained through imitation learning and further do this human alignment and also reinforcement learning in the environments that can handle very complex situation on sidewalk. Right? Now you can see here, this from the person view, the model can output the next 5 seconds, how the model should move around, that is doing this kind of sidewalk navigations. So we will release this papers very soon this week. It's called the Flow Pilot. We also been working on the cross-embodiment deployment of the model. Basically, the autopilot navigation foundation model we trained. So we want to further generalize to many other robots on sidewalks. So here is a demo video showing you that the autopilot model we trained, so we can do this kind of cross-embodiment deployment on a robot dog, like walking on the sidewalk. There are more videos. So we also, in my lab at the UCLA, we also work with many other robots, such as wheel-legged robots. And recently, we modify wheelchairs, like installing some cameras. Then we can also run this autopilot model to like not only deliver the food for the Coco, right? We also can deliver the peoples to the destinations. So we open source a lot of code and papers, so you can scan the QR code to access our work, right? So here I would like to thank all my students, colleagues, and the collaborators at the UCLA and the Coco Robotics. Yeah, thank you.
Absolutely amazing. Lots of great comments in the chat. People very impressed. Wow, great work, and amazing that you're all sharing this with the world, and the developers watching can take advantage of some of these resources. That's really, really impressive, and very just very awesome of you guys. So what is, let me see. So what is, let me take this off the screen for a second. So it's pretty fascinating. What's coming up next for Coco Robotics? What's the plan?
Yeah, so as far as like the business goes, our goals are to grow the business and to scale it. So we're currently deployed in around 5 US cities right now, 2 European. And we're looking to add a lot more European cities. We're looking to add more US cities. We're also looking at Asian markets. So really the name of the game there is scaling the business. As far as kind of technology goes, we want to run bigger and better models on board, and just kind of keep pushing the limits of robot learning.
That's great. And where should people, what's the best place for people to go to follow you? Just Coco Robotics website?
Yeah, so
LinkedIn? Website,
X, LinkedIn, usually we'll post on all those things.
Awesome. Well, we definitely got some good questions here in the comments. So if you guys want, we can start taking those.
Yeah.
And feel free, if you guys want to add anything else, just feel free to jump in. All right. So these are some live comments we got. Some of these came in a little earlier, so I have to backtrack a little bit. I'm not familiar with Blind Square, but let me see. This question's coming in from YouTube, it looks like. How's Blind Square helpful in these situations?
Yeah, so Blind Square was a interesting kind of integration we did. So our robots collect a lot of information about like the cluttered sidewalks we see. Mm-hmm. So any sort of kind of obstructions or potentially dangerous items to visually impaired people, we'll actually send over to Blind Square so that they can kind of help inform people to better get around.
Okay, so very helpful then.
We hope so.
Okay, cool. All right, great. And I have to say, we got hundreds of people watching right now, so lots of interested developers. Okay, here's another question that someone posted. Let me see this. How do you do 3D reconstruction?
It's
this is coming also from YouTube. So,
Bola, you want to take this one?
Yeah, the 3D reconstruction. So we use Gaussian splatting, so which is can directly reconstruct the 3D splat from the videos, like from the RGB videos. So it's can work really well. But there are some conditions, such as if there's some dynamic object, so it won't work so well. But it's a really scalable and efficient way to have this kind of data driven reconstruction. Then we can load into Isaac Sim and use them as an interactive environment. Very cool.
This is a general question, I guess, just on the general business model and the pros and cons. This is coming from LinkedIn. Do you guys have any kind of data on a difference in time between deliveries of normal couriers and a delivery robot?
So I'd say it kind of highly depends on the environment. So there's areas where like we're faster. There's like delivery robots are faster. There's areas where, cars are gonna be faster, right? Compared to a highway, a car is gonna be faster. In a dense urban area where potentially there's lots of congestion, hard to find parking and stuff, we can actually be faster. Also, a lot of times we're like well integrated with the restaurants. So usually we'll get loaded first and we can deliver faster. So it highly depends on kind of the area, but generally in like dense urban areas, we can be faster.
Okay, cool. That makes sense. Okay, this is a kind of a comment and a question coming in from LinkedIn. Impressive work on the navigation foundation models. These robots operate on sidewalks, around pedestrians, kids, pets. At the action layer, when the model decides to move, what governs or constrains an unsafe action before it executes?
Yeah. So we have like a separate safety / governance layer that's kind of gating the outputs of the models.
Got you. Awesome. Okay, makes sense. Thanks for that question. Let me see what else we got. We got a couple other ones here too. His is coming in from Omniverse Ambassador Dylan Tobin. Very cool. How do you verify the scale and accuracy of the assets?
Yeah, so right now for the assets in our Urbanverse, so it's automatically annotated through ChatGPT. So basically we send out several views of the assets, then ask ChatGPT about physical attributes. For sure, and there are some hallucination for some of the asset. So we have some human verifications so after the automatic annotation. So basically the first author and the second author did some verifications for the readouts.
Okay, great. Well, thank you for that question. That was great. Here's an interesting question from LinkedIn. Is there a way for the bots to communicate with each other? You showed some videos with actually multiple robots on the sidewalk at the same time, and one of those scenes looked like for straight out of GTA. So are they communicating with each other in real time?
Indirectly. Some people kind of think of this as mesh networking, where there's like a direct radio link between robots. We don't do that. I guess the way they communicate is we've kind of got like a central backend where we collect information. So this could be like updating maps in real time, and that information will get propagated to the fleet. So no mesh networking, although maybe one day. But they do kind of like we do kind of like centralize the information and then use that to.
Good.
Where to go?
Okay, yeah, one thing to add about this, I think it's also a very interesting research problem, like multi-agent collaborations, right? So we have the robot fleet. So how the robot can share like information about the perception, also share the information about the decision makings will be very interesting. Also, how they communicate with each other, how they communicate with traffic infrastructures. So I think there are a lot of opportunities out there.
Yeah, very impressive. Okay, now we've got a question here coming in from, this is from YouTube, I think. Do you use only video to create simulation, or do you use HD maps also?
Yeah, that's a very interesting problem. So actually for the sidewalk, there is no HD map. So right now we use just the video to reconstruct the simulation environment. But we have some ongoing efforts that we apply some semantic segmentations to segment the reconstructed environment. Then we can create the HD map of the sidewalk. So that will be very useful information, I think, for the community, also for the city councils, so they can measure the weights of the sidewalk and also the quality of the sidewalk, right? So very important for pedestrians.
Very helpful. Okay, great. That's awesome. Another question from another Omniverse ambassador, Itimar. She's asking, there is a plan to deploy on the G1 Unitree humanoid?
Yeah, I think the sidewalk navigation foundation model we developed can be deployed on the humanoid robot. So recently we tested on the booster robot like T1. So I think the same models also can be deployed on the G1 Unitree humanoid.
Very cool.
The model only rely on molecular RGB cameras.
Amazing. I think her work is interesting, actually. She works at doing a digital twin for hospital ICU. to help nurses and others help clinical workflows. So I'm sure that's why she's asked. He's also a professor. So thanks for that great question, Itamar. Okay, let me see. Here's another question regarding how you guys manage fleet updates and deployments. This is coming in from LinkedIn. I guess they're asking about specifically, like, you know, at the end of the day, these go back to the office, and I guess that's where the updates would happen, I'm assuming.
Yeah, assuming operationally, so we'll use like LTE, so cellular data to basically do the updates. Generally our bots are scattered all across the world, so we can't really bring them all back to the office at the end of the day.
Gotcha. Okay, so all done wirelessly.
Yeah.
Okay, here's a good another question from Art on LinkedIn. Have you thought about B2B indoor offices for delivery and movement of supplies? Well, that's interesting.
Yeah, so we actually did an interesting kind of pilot with Zara. So it wasn't office supplies, but it was like clothes in like an outdoor mall, which was interesting.
Oh.
So we get these questions a lot where it's like, oh, what about like, you know, XYZ, or like, and generally like kind of our vision for Coco is we want to be able to move everything around the city. Kind of our main focus right now is like food delivery, just because the market is so large. But we're also looking at like grocery, parcel, as well as kind of some of the other more niche, like moving clothing around and office supplies. You know, so it's on the roadmap at some point.
Cool. Big thank you to Amelia, our producer, who's helping mark all these questions for us. Lots of great questions. Still plenty more coming in. This is another follow-up question from Dylan. How does your system handle deformable or soft-bodied asset regeneration?
Yeah, in our simulation, so right now we have this assumption right now is a rigid object. So, but I think Isaac Sim and Newton's can support this deformable and the soft asset simulation. I think that can be further incorporated in our urban sim simulators.
Okay, great. Great comment there from Dylan. All right, and then let me see. This is coming from YouTube. I guess they want us to clarify how Gaussian splats are converted to meshes for Isaac. I don't know if you want to go into that.
Yeah, so there are multiple ways to reconstruct a mesh from Gaussian splat. So I think the NVIDIA new rack already provides some function that can create mesh like directly from the Gaussian splat. But if you want to have a higher quality mesh reconstruction, so I would suggest to have a better like a data capture system. Like instead of just using like iPhone to reconstruct environment, you can buy a more expensive cameras with lidars incorporated. So use a lidar as a better initialization for the core map. Then you can have a better Gaussian splat reconstruction as well as a mesh reconstruction.
Barry, thank you for that. That's awesome. Here's a question coming in. And we've all seen videos of these kinds of situations coming from LinkedIn. If a bot faces any difficulty doing work, is it going to deal with that difficulty on their own, or does it just stop?
Depends on the difficulty. There's a whole wide spectrum of things we could run into, and generally the goal is always to complete the delivery as fast as possible. Get from A to B as fast as possible. So if we can, we're always going to do our best to get resolve the difficulty as quickly as possible.
Okay, so hopefully it's not going to stop right there. So those are probably really edge cases that obviously when you're learning that you're taking the data from your world use every day, so those get less and less. But that's a great question. All right, here's another one coming from YouTube. What is the teleoperation to autonomy ratio of the fleet navigation currently?
Yeah, so interesting depending how you define this, but generally speaking, like in the videos we kind of showed before, like when the system is driving, like the system is doing everything itself. So right now it's about kind of one operator to one vehicle. So we call it like supervised autonomy. And kind of our goals for this year is to keep increasing that ratio.
Amazing. Amazing. Okay, great. Thank you for that question from YouTube. All right, another one from YouTube. How do you handle anomalies from the perception caused by different surfaces, such as specular objects?
Yes, so
These developers know what they're talking about.
yes, actually in real world sidewalks, so there are all kinds of crazy situations, like the sunset, sunrise, lighting, very poor lighting conditions. So right now our model is a end-to-end driving model. So sometimes we will have, besides like decode the actions, we also try to decode many other like semantic mask or depth map. So we can use this multimodal like decoding radar to help verify the predictions.
Okay, this is great, and I thank you all, Brad and Belay, for being so open and transparent with these answers. It's super helpful for the developers out there. Speaking of open and transparent, this is coming in from YouTube. Open source environments available for autonomous robots, especially for last mile delivery to train on it. Yeah, how does this differ from what you guys have open sourced and made available?
Yeah, so we already open source our urban sim simulators built on top of NVIDIA Isaac Sim. So you already can start using that. Also for the assets in Urbanverse, we also release all the 100,000 assets, so you can use to build your own urban environment. So compared to the previous simulators built on top of NVIDIA Isaac Sim, so we focus more on the urban simulation. Previous Isaac Sim mainly focused on the indoor object manipulation, right? So there are only a limited number of objects the robot can interact with. But in the real world urban simulation, urban environments, so there are huge amount of objects. So we want to simulate. So I think our work can fill the gap for this kind of urban simulations in the NVIDIA Omniverse ecosystem.
That's great. And Amelia will post that link again in the chat, but you guys also, if you're watching this live, after this is done, you could go back to the same link and rewatch this and early in the presentation in the slide deck. There was a nice QR code for everybody, but also we're posting links in the live chat. So thank you for that question coming in from YouTube. Okay, and now we have another question coming in from LinkedIn. This is coming in from Benny. How do you manage robots being stuck or immovable situations? What are the recovery approaches implemented? Yeah, what have you guys done when this happens? I guess you have someone comes out there and retrieves?
So generally what we'll do is we'll kind of like update our maps in real time that like this area is blocked, and then we'll reroute it. And if that happens sufficiently enough where there's no physical way to get from point A to point B, then we'll either have to, cancel the delivery or send someone out.
Okay, cool. Thank you for that. And I think this is the last question. Let me see. This is coming in from YouTube. Will using WAM be better now for autonomous delivery robots?
WAM.
WAM. Yeah, we might need a clarification on that. So do you want to take a guess?
Action model?
Potentially. I know if you want to add some more details to that question, and maybe we can help, but it's unclear what you're referring to there.
Yeah, if it's a word action model, I think it's an interesting comparison to the Isaac Sim, which is a graphic based simulation. So I think there will be a lot of potential there, like the use word model, like a video generation model, to create the simulation environment that we can use for training and testing. But one limitation or drawback there is how can we get a more real-time, precise action feedback from the word model. I think there are a lot of issues to be solved before we can use that.
Okay, great. All right, let me see. I think is that it for the start questions? Oh, one more just popped in. Okay, here we go. Lots of questions and comments. This is coming in from YouTube. Follow-up question on specular objects regarding multimodal sensor fusion for perception verification. Both LiDAR and depth cameras fail with reflective specular surfaces such as water on street. I guess there's a question in there. Question with a period. Yeah, I don't know if you wanted to.
But that's all you.
Yeah, it's actually challenging, right? So the reflective surfaces, so the robot sometimes cannot correctly recognize, but the human will provide the feedback. If this case, the robot may make mistake, the human will provide feedback. Then we have some learning mechanism like the train the model from human feedback to further improve its capabilities. Right. So that will be our current solutions, like better learn from human feedback to improve the model.
Amazing. All right. Well, again, I think that wraps up the questions. So thank you, everybody watching. We got hundreds of people watching right now. This is fantastic. If you jumped in the middle or any other point in the live stream and you watch it again, this is on our NVIDIA Omniverse YouTube channel. If you go to the live section, you'll see all of our live streams and you can rewatch this at your favorite pace, whether you want to watch it sped up or slowed down. Some amazing information shared in this hour, starting off with Max and talking about agent skills. And then my colleague Katie came on and gave a nice overview of the Isaac Sim 6.0, which has now hit general availability. And of course, our stars of the hour have been our friends here from Coco Robotics, talking about their autonomous delivery company and all their work with NVIDIA Omniverse tech stack. Before we go, I'm curious. So this goes to Brad and Belay. Like, what do you think is the most important thing that you want developers to take away from this hour? If they're going to kind of remember one thing, you guys have shared a lot of information and a lot of great news about how Coco Robotics has evolved from the beginnings. What do you want people to take away from this? I'll start with you, Brad.
Yeah, I mean, from the talk, simulation, super important if you're a roboticist. I'd highly recommend making it like a first-class citizen in your development workflow. Yeah, I mean, NVIDIA is putting out a bunch of really good products that help make the whole process easier. So.
And what cities are you guys in right now? So LA?
So LA, San Jose, Chicago, Miami, Jersey City are the US ones. In Europe, we're in Helsinki and Turku, which are 2 Finnish cities. And we're looking at a few others kind of across Europe, US, and Asian markets.
Amazing. And so people can look out to those when you're traveling or if you live in those cities. It's pretty exciting. What has been the most challenging city based on environment or weather or the way the sidewalks are?
Each one has its own challenge. If anything, you could argue LA is the easiest, like best weather. It's like our backyard and we're local. Chicago is hard because it's really cold. Miami is challenging because torrential downpours and the pedestrian infrastructure is not good. And then Europe is challenging because we're based in LA, so kind of distributed team. But every city, for some reason, has something unique and hard about it.
Yeah. Well, that's great that you guys are on top of it, and that simulation is a big part of how you address these challenges. Belay, what would you like to leave people with?
Yeah, so in the era of large language model training, so people believe in the scaling law. But for robotics, especially the real world robotics, I think scaling law is not the only oracles. We still need to augment the scaling law with all the synthetic data generation and also simulations, as well as interactive human feedback, such that we can build a better and more reliable and safe robot.
Well, I think that is super helpful information for everybody. I think that this has been an amazing hour. I want to thank you both for spending time and preparing the presentation materials and giving such nice, thoughtful information. Also sharing so much information with the public. I think that's just awesome. And all your great answers to the questions that we had. I'm going to spend a couple minutes talking about some upcoming stuff happening. I'm going to let you two go. But again, thanks again for the great conversation. It's been a really fun time.
Yeah, thank you.
Thank you.
Yeah.
What a great team, Coco Robotics. It's definitely a company that everyone should follow on LinkedIn. Check out their website. I think it's so great that they are sharing some information with the general public so developers could make full use of this. Speaking of developers making full use of things, As some of you noted earlier in the stream, yes, I'm back from GTC Taipei. It was amazing. I'm actually planning a live stream with some great developers I met there. If you're watching, I already missed you. We had a great meeting every day. We called it our breakfast club. We're going to have them on soon, and we'll talk about some of their takeaways from GTC Taipei. But it's a good reminder how impactful these networking events are, like GTC or Computex, SIGGRAPH coming up also. We'll post a link in the chat, but we've got GTC Berlin coming up in addition to SIGGRAPH. We'll be a heavy presence, obviously, both of them, definitely GTC, since it's our conference, but we're also going to be in full force at SIGGRAPH. Lots of cool sessions around physical AI there. And if you can't make these events and network developers on site, don't worry about it. Those sessions available, even though the networking is not the same, not being there, the sessions and the informational content, we do our best to put that out on NVIDIA On Demand as quickly as possible. So sessions from last week at GTC Taipei should be available on NVIDIA On Demand very shortly, if not already. So great information in all those sessions. Developers were really came away with some great learnings. The other great thing about going there, if you can make it there, in addition to networking, is seeing the live demos and the expo area where partners and customers and other developers are showing off how they're leveraging some of the latest technology. We saw a lot of really interesting things there, already leveraging Cosmos. Coming up on our next live stream, actually. So today we have our Isaac Sim and Isaac Lab study group, which takes place every Wednesday at 12:30 p.m. Pacific. If you're watching this live, that means in about 20 minutes, this kicks off on our Discord server. And you can just go to discord.gg/NVIDIA Omniverse. We'll post a link in the chat. It's a great, no pressure hangout for Isaac Sim and Isaac Lab developers to ask questions, show and tell projects, talk about the latest announcements. I bet you they're going to be talking about Isaac Sim 6.0. So go ahead and add that to your calendar, jump in the Discord server. But we've got some amazing live streams kicking off. Also, 3 live streams this week. We have getting started with NVIDIA Cosmos 3 for robotics tomorrow. That's going to be at 12 p.m. Eastern, which is 9 a.m. Pacific. And then we also have a generate synthetic data physical AI with NVIDIA Brev launchables and agent skills also happening tomorrow. Tomorrow's a busy day. And then, of course, we have our weekly OpenUSD study groups happening on Friday, which are led by Omniverse Ambassador Michael Wagner for our European developers, and in US, Nandu Valal. So great, both OpenUSD study groups. No need to pay anything or go anywhere. These are all virtual. Super exciting stuff. We'll post a link to our calendar. We have lots of amazing events coming up. We hope you are able to attend. Again, just a reminder, I believe word on the street is that GTC Berlin registration opens up next week. I don't have a specific firm date on that, but if you go to the website, we'll post in the chat for GTC Berlin if you're in Europe and can make it. I highly recommend you go to the website, go to notify me. You'll get a notification when registration opens up. There is I say this every time, and it becomes quicker. It happens quicker and quicker. It will sell out. GTC Taipei also sold out much quicker than we anticipated. I have a feeling that Berlin will also sell. So I want to make sure that our developers, our community, many of whom watch these live streams, do not wait on registering. If you think you're going to go, you should register as quickly as possible. And I would also secure your hotel room so you don't have to walk too far every day. I will be there as well as many people on our team. And so we're going to set up. We've already set up a thread on our Discord server to chat about plans. As we always do, we set up a very impactful WhatsApp group for our on-site attendees. So we're going to set that up for Berlin. So if you know you're going, let us know. We'll add you to that WhatsApp group so you can start chatting with us and other attendees and start making your plans. The meeting application brain date will be available for GTC Berlin. Super exciting. So people have a very easy way to network with each other and set up meetings. I think that's very impactful for a relationship. So take full advantage of that once it's released. I want to thank everybody, especially our friends at Coco Robotics and my colleagues Katie and Max for sharing the latest happening on our side. And I want to thank all of you for watching and asking your great questions and making these great comments. Always make these live streams a really fun part of our week. and probably the best part of my day. So thank you so much for joining me today. It's been an honor. I'll see you tomorrow for those other live streams. Until then, have a great rest of the day.